In Lesson 5.4, you will solve and graph compound inequalities. Remember that a compound inequality containing the word "and" is only true if both inequalities are true. It is the intersection or overlap of the two inequalities. In the first example, we're going to take this compound inequality and separate it out into the two inequalities. I'm going to start with this part right here. So I'm going to go ahead and write that one down. X minus 3 is greater than or equal to negative 2. Now to solve it, you would add 3 to both sides. And you get x is greater than or equal to 1. And now I'm going to go ahead and solve the second one, the second half, this piece right here. X minus 3 is less than 4. To solve this inequality, you would add 3 to both sides. And you will have x is less than 7. When you come across an inequality like this, written this way, it is one with the word "and" in between them. So I'm going to first go ahead and graph the first one. X is greater than or equal to 1. Means I'm going to put a filled in circle on the 1. And the ones greater than that are to the right. Now for the second inequality, that solution was x is less than 7. So we're going to have an open circle on the 7. And the numbers less than 7 are to the left. And now since this is an "and" compound inequality, we want the overlap or the intersection of these two. So if you visualize putting these two on top of each other, the part where they overlap is a filled in circle on the 1, an open circle on the 7, and the numbers in between there are a solution. And then the way we can write this solution is like this, where we're going to put x in the middle, and it's less than 7 and greater than or equal to 1. So you could write them both separately like this with the word "and", or you could write it just like this. You may want to pause the video and try the next one on your own. This is another "and" compound inequality, so I'm going to go ahead and write the first one down. R plus 7 is greater than or equal to 6. Remember, when you flip these two sides around, you have to also flip the inequality symbol around. Now to solve this, we would subtract 7 from both sides. So r is greater than or equal to negative 1. And then the second one is going to be this piece right here. R plus 7 is less than 10. And when we solve that inequality, we subtract 7 from both sides. R is less than 3. And again, this would have the word "and" in between them. Now let's go ahead and graph the first one. R is greater than or equal to negative 1 means we're going to fill in the circle on negative 1. And the numbers greater than or equal to it go to the right. For our second one, we would put an open circle on 3. And we want the numbers less than 3, so we're going to go to the left. Now our solution is the intersection or the overlap of those two graphs, which means we're going to have a filled in circle on negative 1, an open circle on 3, and it is all of the numbers in between there. So you could write your answer like this, or you could put the R, and then it's going to be the numbers less than 3 and greater than or equal to -1. A compound inequality containing the word or is true if at least one of the inequalities are true. The solution is the union of the two inequalities. So if I want to solve and graph this compound inequality, I'm going to start with this one right here. -2m plus 7 is less than or equal to 13. We'd start by subtracting 7 from both sides. So a -2m is less than or equal to 6. Then I would divide both sides by -2. And since I divided by a negative number, we have to flip the inequality symbol around. So m is greater than or equal to -3. And then our other inequality, 5m plus 12 is greater than 37. Now to solve this, we would subtract 12 from both sides. And you're left with 5m is greater than 25. Divide both sides by 5. And we have m is greater than 5. And this compound inequality has the word or. So we're looking for the numbers that are greater than or equal to -3 or the numbers that are greater than 5. So if we wanted to graph that, we'd start with the numbers greater than or equal to -3, means we would fill in the circle on -3, since it includes -3. Greater than goes to the right. And then we would take the numbers that are greater than 5, so an open circle on the 5, and it goes to the right as well. Now, if we're looking for the numbers that are in this one or in this one, they don't have to be in both. So we're not just looking for the overlap, we're looking for everything. And the red graph includes all of the ones from the green graph. So our solution to this compound inequality is all the numbers m greater than or equal to -3. You may want to pause the video and try the next one on your own. We'll go ahead and solve the first inequality. A plus 1 is less than 4. You would want to subtract 1 from both sides. So A is less than 3. Now we'll solve the second inequality. A minus 1 is greater than or equal to 3. We would add 1 to both sides. So we have A is greater than or equal to 4. And we have the word or in between these two. So let's first graph the numbers less than 3. We'd put an open circle on the 3, and the numbers less than 3 go to the left. Now we're going to graph the numbers greater than or equal to 4, means we are going to fill in the circle on 4 and go to the right because those numbers are greater than or equal to 4. And now if we wanted the union of these two, the solution can be in this graph or in this one. It doesn't need to be in both. Therefore, our solution is going to look like this. because we're looking for the numbers that are in this one or in this one. So here's our final solution. Numbers less than 3 or greater than or equal to 4. Now the last thing we're going to do is just the reverse. We're going to look at a graph and we're going to write the compound inequality. So for this one right here, this is going to be one of those AND ones. Notice the AND compound inequalities are usually a chunk of the graph, like right here and right here. It's between two numbers. So here, we're going to put x in the middle, and we want it to be less than or equal to 2, and we want it to be greater than, since it's an open circle, -3. Now for our next one, this is going to be an OR. The numbers can either be less than -4 or greater than -3. So we're going to say x is less than -4 or x is greater than -3. It doesn't include the -4 or the -3. That's why we chose these symbols. And the last one, this is going to be another OR because they can be here or here. So x can be less than or equal to -3, or x can be greater than 0. But it doesn't include 0, so we just use the greater than symbol.